Hi folks, we're going to take a look at number 21 from page 377. So here they tell us that the expression 2 to the a is equal to 5 and the expression 2 to the b is equal to 3. And they want us to use that information to determine an expression for log base 3 of 10. All right, now the textbook actually gives it as a multiple choice. All right, so we'll just try to solve and then see which answer is appropriate. All right, so I'm noticing here a logarithm with base 3, and here I'm noticing exponential expressions with base 2. So I should be thinking already that I might be having to do a change of base at some point in this process. All right. So since I'm trying to find this logarithmic expression, what I'm going to do is I'm going to take these exponential equations and write them in logarithmic form. Okay. So how can we rewrite this in logarithmic form? Well, by taking the log base 2 of both sides. Because if I take log base 2 of 2 to the a, I'm just going to get a, and then here I'm going to end up with log base 2 of 5. Okay, I'm going to do the same thing here. Take log base 2 of both sides. So the left-hand side is just going to give me b, and the right-hand side is going to give me log base 2 of 3. All right, but what I'm trying to determine is log base 3 of 10. All right, so what I think I'm going to do is change this logarithmic expression into a logarithmic expression using base 2. So at least I'm working with the same types of logarithms throughout. And of course, I can do that by using my change of base formula. So the change of base formula says that this logarithm is equivalent to the log base 2, whatever base I want to change it to, all right, of the original input over log base 2 of the original base. All right, and there you go. Right away, I see that this expression in the denominator is just equal to b. All right, so that's already a good start. In fact, if you look at the multiple choice option, I can see that I've already narrowed down to just a couple of options because the denominator has to be equal to b. The only difference here is that the numerator is log base 2 of 10, and what I have is log base 2 of 5. So I need to find a way to relate this expression to one that I have. And this is where I think, well, what's the relationship between 5 and 10? Well, 10 can be written as 2 times 5. All right, and this is where I hope you remember that the logarithm of a product can be written a different way. I can use my first logarithm law to write the numerator as log base 2 of 2 plus log base 2 of 5. All right, and right away I see that I've determined an expression which is exactly the one that's equal to a. And what makes this work out nicely is that log base 2 of 2 is something I can evaluate because 2 exponent 1 is equal to 2. So this is just equal to 1 plus a over b. All right, so we've managed to write this expression in terms of a and b. And if you're interested, if you look there, it looks like the answer is C. They have it written as a plus 1 over b, which of course is equivalent to this one here. So let's do a recap because this is a little different from some of the problems we've seen. So step 1 was to notice that I had two exponential expressions with base 2 and a logarithmic expression with base 3. So right away that gave me a sense that I was going to do some sort of change of base at some point. Step 2 was to turn these expressions into logarithmic ones, okay, since I'm trying to determine something that's logarithmic. And then from there, I did my change of base, noticed how one of those expressions gave me one of my variables b, and the other one I needed to do a little bit of algebra. I needed to notice that I was given information about log base 2 of 5. I had log base 2 of 10, so to just split it up as a product so I could make use of the first logarithm law. Okay, that's it for this one.